Equations involving one variable and having maximum index of the variable 2 are called quadratic equations in one variable. When the quadratic polynomial ax square plus bx plus c is equated with 0, then it is called a quadratic equation. In other words, the equation of the form ax square plus bx plus c is equal to 0, where a, b, c are real numbers and a is not equal to 0, is called a quadratic equation in variable x. The general or standard form of a quadratic equation is ax square plus bx plus c is equal to 0. The term quadratic comes from the Latin word quadratus, which means square. In the quadratic equation ax square plus bx plus c is equal to 0, the constants a, b and c are called the quadratic coefficient, linear coefficient and the constant term or free term, respectively. Let us do an activity. Fill in the blanks with appropriate answers and complete the table. The quadratic equation x square minus 4 is equal to 0 is written in the standard form as x square plus 0x minus 4 is equal to 0, where a is equal to 1, b is equal to 0 and c is equal to minus 4. Similarly, we write the quadratic equation y square is equal to 2y minus 7 as y square minus 2y plus 7 is equal to 0, where a is equal to 1, b is equal to minus 4 and c is equal to 7. For the third quadratic equation, we write the standard form of the equation as x square plus 2x plus 0 is equal to 0, where a is equal to 1, b is equal to 2, and c is equal to 0.
Consider a quadratic polynomial px is equal to x square minus 5x plus 6. We will now find the value of px by substituting the given values for x. What is the value of px when x is equal to 0? When x is equal to 0, the value of px is 6. This means p at 0 is equal to 6. What is the value of px when x is equal to 1? When x is equal to 1, p at 1 is equal to 2. What is the value of p at minus 1? P at minus 1 is 12. In the same way, on substituting x is 2, minus 2, 3 and minus 3, we get p at 2 is equal to 0. P at minus 2 is 20. P at 3 is 0. And p at minus 3 is 30. For which values of x is the value of the polynomial px 0? Yes, the value of px is 0 for x is equal to 2 and x is equal to 3. Therefore, 2 and 3 are called the zeros of the quadratic polynomial x square minus 5x plus 6. But this method of finding the zeros is tedious. How do we then determine the zeros of the quadratic polynomial in an easier manner? Zeros of the quadratic polynomial can be obtained by equating the quadratic polynomial ax square plus bx plus c to 0 and solving the equation. Every quadratic polynomial has at most 2 zeros. We will now learn to identify quadratic equations. How do we decide whether the given equations are quadratic or not? we will have to compare the equation with the general form of quadratic equation ax square plus bx plus c equal to 0 to decide if it is quadratic or not. Consider the first equation, x square minus 5x plus 4 equal to 0. What is the value of a here? On comparing with ax square plus bx plus c equal to 0, a, the coefficient of x square, is 1. Similarly, by comparison, b, the coefficient of x, is minus 5 and the constant term c is equal to 4. Here a, b, c are real numbers and a is not equal to 0. Therefore, x square minus 5x plus 4 equal to 0 is a quadratic equation in variable x. Consider the equation y square minus 4 equal to 11y. First, let us write the equation in the standard form. The equation becomes y square minus 11y minus 4 equal to 0. Now, we will compare it with ay square plus by plus c equal to 0. What are the values of a, b and c? A is 1, b is minus 11 and c is minus 4. Here a, b, c are real numbers and a is not equal to 0. Can we say y square minus 11y minus 4 equal to 0 is a quadratic equation? Yes, it is a quadratic equation in variable y. Consider another equation. 11 is equal to minus 4x square minus x cube. This equation can be written as x cube plus 4x square plus 11 is equal to 0. Is it a quadratic equation? No, it is not a quadratic equation. Why? X cube plus 4x square plus 11 equal to 0 is not a quadratic equation because the highest power of the variable x is 3. Let us consider another equation. N minus 3 is equal to 4n. We can write this equation as minus 3n minus 3 equal to 0. When we write this equation in the standard form of quadratic equation, it becomes 0n square minus 3n minus 3 equal to 0. Comparing with an square plus bn plus c equal to 0, we get a is equal to 0, b is equal to minus 3 and c is equal to minus 3. Since a is equal to 0, it is not a quadratic equation. N minus 3 equal to 4n is a linear equation in variable n since its degree is 1. The next equation is 3y square minus 7 equal to root 3y. Writing the given equation in the standard form, it becomes 3y square minus root 3y minus 7 equal to 0. Comparing with ay square plus by plus c equal to 0, a is 3, b is minus root 3, c is minus 7. A, b and c are real numbers and a is not equal to 0. Therefore, the equation 3y square minus 7 equal to root 3y is quadratic in variable y. Let us consider one more example. Q square minus 4 upon q square is minus 3. First, we will write the equation in the standard form. Cross multiplying, we get q square minus 4 is minus 3q square. On simplifying, we get 4q square minus 4 is equal to 0. This can be written as 4q square plus 0 into q minus 4 is equal to 0. Comparing with aq square plus bq plus c equal to 0, a is 4, b is 0, c is minus 4. A, b and c are real numbers and a is not equal to 0. Therefore, the equation q square minus 4 upon q square is minus 3 is quadratic. In the next question, we have to write the given quadratic equations in the standard form ax square plus bx plus c equal to 0. The first equation is x square is equal to minus 7 minus root 10x. How do you write this equation in the standard form? We will shift minus 7 minus root 10x from right hand side to left hand side. Therefore, the equation becomes x square plus root 10x plus 7 equal to 0. And this is in the standard form ax square plus bx plus c equal to 0. The second equation is p into p minus 6 is equal to 0. By using distributive property, we get p square minus 6p is equal to 0. Which term is missing when compared to the standard form of the equation? The constant term is missing. By adding 0 for the constant term, we can write the equation in the standard form as p square minus 6p plus 0 is equal to 0. The third equation is x square upon 25 minus 4 is equal to 0. To remove the denominator 25, we will multiply all the terms of the equation by 25. Therefore, the equation becomes x square minus 100 is equal to 0. Which term is missing when compared to the standard form of the equation? Here, x term is missing. Hence, by adding 0 to the x term, we can write the equation in the standard form as x square plus 0 into x minus 100 is equal to 0. The fourth equation is 2z minus 5 upon z is equal to z minus 6. In this equation, one term contains z in the denominator. How do you remove z from the denominator? By multiplying all the terms by z, we can remove z from the denominator. Multiplying throughout by z, the equation becomes 2z square minus 5 is equal to z square minus 6z. On simplifying and arranging the terms, this equation can be written in the standard form as z square plus 6z minus 5 equal to 0. The fifth equation is m square plus 5 upon m square is equal to minus 3. Here we have to remove m square from the denominator. By cross multiplying, the equation becomes m square plus 5 is equal to minus 3m square. That is 4m square plus 5 equal to 0. By writing 0 for the missing term m, we get the standard form of equation as 4m square plus 0 into m plus 5 equal to 0.